Hello everyone, welcome to our channel. I'm Gong and she is Wan. Today we are going to introduce geothermal energy. We will introduce geothermal energy from the following aspects: utilization of geothermal systems, production in some countries, global geothermal energy production, how to produce geothermal energy, the impacts of geothermal energy on the environment, its advantages and disadvantages, and challenges. And finally is the future of geothermal energy. First of all, what geothermal energy is and its source and history. In fact, geothermal energy is quite common in our lives. For example, hot spring is a kind of geothermal energy. It is an energy inside the earth. Most geothermal resources are located near the boundaries of the Earth's tectonic plates. As you can see from the picture, one of the most active geothermal areas in the world is the Ring of Fire around the Pacific Ocean. The use of geothermal energy can be traced back a long time ago. The earliest industrial mining began in Italy in 1827.
In this part, I will introduce the use of geothermal energy. About 70 countries in the world use geothermal energy. There are three ways to use geothermal energy: direct use, geothermal heat pumps, and power generation. The first I'm going to talk is direct use. This method is probably the most widely used method because it is the simplest to use directly and does not require any special equipment. This method uses low-temperature geothermal resources with a temperature range of about 50 to 150 degrees. Most of this type of use is to directly use lower temperature geothermal water or steam to heat buildings, which is relatively common. In addition, there are hot springs directly heated by the geothermal heat. The second is the geothermal heat pump, let's say GHP. GHP uses geothermal energy within 300 meters of the surface. In this part of the lithosphere, the temperature is about 5 to 30 degrees. GHP is mainly used for heating of buildings in winter and cooling in summer. As can be seen in this figure, the entire system is a circle consisting of pipes, pumps, and heat exchanger. In winter, geothermal energy pumps hot fluid to the building for heating, while the cold fluid in the building is sent to underground pipe for heating. Also, in summer, the pump can draw cold fluid or steam from the building and then circulate underground to dissipate most of the heat and return to achieve refrigeration. Finally, geothermal energy is used to generate electricity, which usually requires the fluid to have a higher temperature, which means the deeper geothermal energy needs to be developed. There are about 5 processes using geothermal energy to generate electricity. We can see from this picture here. First, hot water is pumped into the well from high pressure deep underground. Second, the water reaches the ground. The pressure drops, which causes the water to become steam. Third, the steam rotates the turbine, which is connected to a generator that generates electricity. Fourth, the steam cools and condenses back into the water. Fourth, the steam cools and condenses back into the water. Finally, pump the cold water back to the ground and repeat the process. On the left of this figure is a dry steam station, which is the simplest and oldest design. Although this method has high efficiency and the simplest facilities, This type of power station is not common because it requires geothermal resources that can produce dry steam. This has great restriction on the choice of power plant address. The middle is flash steam station. It uses deep underground high-pressure hot water instead of directly using steam. High-pressure hot water is pumped from the underground to the surface. The pressure drops cause the hot water to boil and produce steam. This is the most common station type in operation today. On the right is the binary cycle power plant, which is the latest development. The flue used in this method may be a geothermal flue as low as 57 degrees. Geothermal hot water flows through the auxiliary fluid, which has much lower boiling point than water, causing the auxiliary fluid to flash and then drive the turbine to work. This sounds great, but the application of this method is not very wide.
As environmental issues drive the widespread use of renewable energy, geothermal energy is very popular as a renewable energy source. Figure 5 is the geothermal power generation in the State Sustainable Development Plan for 20,000 to 2030. It can be seen according to IEA statistics. Geothermal power generation in 2018 is estimated to increasing by 5% compared to the average growth rate of the previous 5 years. It is estimated that the power generation capacity will reach 282 TWh by 2030. Next is an introduction to geothermal energy production and energy consumption in some countries. It can be seen from the figure that the United States of geothermal energy utilization are most, while Africa and South America use less geothermal energy. The United States has the largest installed capacity of geothermal energy in the world, but geothermal energy is not as widely used as wind energy and solar energy. The technology is not so mature, and some restrictions. As a result, geothermal power generation accounts for only 0.4% of national power generation. We also searched for the country with the highest proportion of geothermal power generation. As you can see from the picture on the right, Iceland ranks first, with geothermal energy accounting for about 25% of all energy.
In this part, I'm going to talk about the environmental impact of using geothermal energy. We know that no matter what form of energy has a negative impact on the environment. Geothermal energy is already a relatively harmless technology, but let's see. First is affect water quality and water use. Most geothermal water contains large amounts of sulfur, salt, and other minerals. After use, the water will still return to the geothermal layer to prevent pollution and ground subsidence. Part of the extracted water will be evaporated, so external water is needed. Second is exhaust gas emissions. In the process of using geothermal energy, some gases will be emitted, such as carbon dioxide, hydrogen sulfur gas, and they will cause air pollution. Third is land use. Drawing hot water from the ground will cause the ground to collapse. The geothermal resources themselves are more located at the junction of the continental plates, and geological activities are active. So if they are not careful, they will cause geological disaster. Despite this, the negative impact of geothermal power plant on the environment is much smaller than that of fossil fuel power plants. It can be seen from this figure that the life cycle emissions of geothermal power plants are not high. This shows that it is indeed environmentally friendly. Here are some advantages and disadvantages of geothermal energy. First is geothermal energy is a renewable resource, which means that the use of geothermal energy is more environmentally friendly. Resources are stable. Geothermal energy is not affected by weather changes, disasters, and fluctuations in fossil fuels price. No fuel required. Fuel-free power generation can reduce carbon dioxide and other greenhouse gas emissions, save money for users. The efficiency of geothermal power plants is very high, up to 90%. Disadvantage: there are potential emissions. The development of geothermal energy must destroy the crustal structure, and the greenhouse gas on the surface of the Earth will migrate to the ground and atmosphere. Impact on the land may cause ground subsidence and earthquakes, but this problem can be solved. High-cost exploration: it may reach $10 million, leading to high total power generation cost and increasing investment risk. Geothermal energy can only be used locally. Because geothermal energy is difficult to transport over long distance, it can only be used in areas near geothermal resources. The last one is electricity cost of pump.
There are also some challenges in geothermal power generation, including explosion of geothermal energy, collection, risks involved, environmental issues, and costs. So we divided into three areas: economic and risk challenges, location challenges, social challenges. The figure shows the risk and the costs of the entire process of developing and applying geothermal energy. It can be seen that the economic risk of the early exploration and excavation work of the geothermal power plants are pretty high, while the operational risks of the later stage are relatively low. The early costs are also high because geothermal wells and power plants must be built at the same time. The capital cost of the geothermal power plants is later in the project, with low operating costs and low risk. Low operating costs and can compete with coal. The main limiting factors for geothermal energy development are the high initial investment costs and the high investment risk of construction facilities and infrastructures. Some challenges and disadvantages of geothermal energy are repeated. As we mentioned before, for geothermal energy, there are high restrictions on the installation location because geothermal energy is difficult to transport over long distance. It can usually only be developed and used locally. It is more suitable for installation in areas where the connection plant is active. This is why the use of geothermal energy varies widely between countries. Residents may not accept noise and environmental pollution from deep drilling.
The last thing we want to talk about is the future outlook. Geothermal heat has become increasingly popular due to its advantages. Geothermal power generation is also increasing. It's estimated that by 2050, global geothermal power generation will reach 140 gigawatts. Not only will power generation increase, but future power generation technology will also improve. For example, The current newer technology is an enhanced geothermal system. Traditional geothermal power plants usually inject wastewater into reservoirs, but their natural cracks in the ground will be closed by some mineral deposits, resulting in poor permeability. However, EGS re-injects high-pressure water into those deep rocks, usually dry hot rocks, to reopen natural cracks. Then the flows into extraction well. If high-pressure water is continually injected to provide a stable source of water, these cracks may remain open. This method can make the location selection more flexible. The enhanced geothermal system is a man-made reservoir created in places with hot rocks but insufficient natural permeability or flow saturation, which means that there is no need to build and expand power plants in areas with geothermal water. Here are the references used. Thank you for listening. Goodbye.